Assalamualaikum, this is Ahmed Maz Ali. I provide a one-stop solution to all your physics, chemistry, biology, and mathematics needs. If you want one-on-one lessons, contact me at the WhatsApp number given below or the email address. In this video, we're going to solve some of the questions related to equation of a straight line. This is a set of questions given by a student, and I will be solving a few of them in the video series. So in this video, I'll do question number 1 and I'll tell you the basics on how to handle equations of a straight line. So far, a prerequisite knowledge is that you must be familiar with what an equation of a straight line looks like. That is, y is mx plus c, in which y is the y coordinate, of course, x is the x coordinate, c is the y-intercept. C is the point where your graph cuts the y-axis. Yeah, so c is the y-intercept, and m is your slope or your gradient. With that knowledge in mind, let's move on and solve the question which says find the slope of the line through 4, 5 and -1 and 2. We're given a point, let's say a point A, which is 4 and 5, and point B is -1 and 2. And we have to find the slope of the line which passes through these 2 points. Yeah, so let's say A is over here somewhere around 4x is 4 and y is 5. So A lies somewhere over here, and B is at x minus 1. This is x minus, this is x minus 1, and y is 2. So somewhere over here. So this is a line, and we have to find the gradient of this line. Yeah, it's very easy to find gradient of a straight line. It has a very basic formula. Basically, you're trying to find out the slope. What is the rise over run? How much is the graph rising? This is the rise. And how much is the graph running, right? So gradient or slope or m is given by rise, which is the change in y-axis. How much has the graph gone from initial point to the final point? How much has there been a rise? And then the run, how much has your graph gone in this direction, right? So which is change in x-axis. How do we find any change? We always find the change by subtracting the final value from the initial value, right? So this is, let's say, your highest value or the later value. If you're looking at the x-axis, you need to start looking from the right side first, right? So and then you'll subtract the left side. So y was 5 and its initial value was 2, right? So this is the higher value, which is y2, and this is the lower value, which is y1. Similarly, y2 will correspond to x2 and y1 will correspond to x1, right? So this is the change in y-axis, rise up. The graph has gone from 2 to 5, and in x-axis, the run, our coordinates were 4 and -1. A simpler way to understand is gradient is y2 minus y1 upon x2 minus x1. Yeah, so y2, what is y2? Y2 is, as I told you, will be the value which is at the right side always. Sometimes the graph can go down as well. And for example, if these are your 2 points, point A and point B, then your y2 will be the value which is on the right side. Yeah, this will be x2 and this will be x1 and this will be y1. Do not get this confused. So y2 over here is this point, which is 5, right? And y1 is this point over here, which is 2. X2 is 4. X1 is -1. Yeah, we got the same thing as we had over here. So let's solve this. 5 minus 2 gives us 3, and then we have 4 minus 1 gives us 4 plus 1. So we are looking at 3 upon 5. So 3 upon 5 is the gradient for this slope. Of course, it's a positive gradient. It gives us 0.6 as well. A positive gradient means the graph is going up. Had it been a negative number, then it would show something like this. The slope is going down. And if the gradient was 0, then the slope would have been 0. If there is no slope over here, of course, it's a flat line. So gradient is positive, we move upwards, always going towards the right side. The gradient is negative, we move downwards while still moving towards the right side. And if gradient is 0, that shows that there is no slope. We are on the same line. Yeah. Let me know if you have any other questions. Do contact me for one-on-one classes if you need any help in your studies. Good luck.